through our work with exponents, many of you have asked the question, well, what if we're trying to solve for an exponent? How can we do that without graphing it on our calculator, without guessing and checking? We're going to start to investigate this question today. So notice this equation has x's in the exponent. The method we're going to use to solve this for today is we are going to try to get the bases to be the same number. Now, many of you would say, oh, well, let's do this. Let me do 3 squared and that'll change into 9. There's two major problems with this thinking. One of which is thinking about algebra. If I do something to one side of the equation, I have to do it to the other side of the equation as well to keep the equation balanced. So if I square the left and square to the right, that my bases are going to be different again. The other reason this is not mathematically correct is because this 3 is a base here. So when I use the power-to-power law, that base stays the same, and my exponents would just multiply together. So I would get 3 to the 2x, not 9 to the something. So there has to be another way to make the bases in this equation be the same. And we can do that by substitution. We are going to substitute a value for 9 that has a base of 3. So we should all know off the top of our heads that 3 squared is the same thing as 9. So instead of a 9 here, I'm going to substitute 3 squared. That way I haven't changed the value of the right side of the equation, I have just changed how it looks. And now I would use my power-to-power law. So I'm going to multiply these two exponents. So this would be 3 to the 2x minus 2 is equal to 3 to the x. And now with these bases being the same, we can actually ignore the bases and just work with the exponents. So we'll get x equals 2x minus 2. Minusing the 2x over to the left will make negative x equals negative 2. So x will equal positive 2. And going back here to our original equation, just as a quick little check to make sure that's the exponent that's going to work, if I plug in a 2, 3 squared is 9. And over on the right side, 2 minus 1 is 1, and 9 to the first power is 9. So in your notes, you're going to want to jot down these 3 steps that I just followed. Number 1, get bases the same by substituting an equivalent value. Number 2, use the power-to-power law. And then number 3, once you've got those bases the same, just get rid of them and solve the equation that's in the exponents. So let's try this equation. 8 to the x minus 1 is equal to 2 to the x plus 5. So we need to change the bases. I would say we could change the bases into 2's because 8 is the same thing as 2 cubed. And you can see the better you know your exponents, the easier this is going to be to spot how to substitute. So there's my 2's. Now over on my left, the power-to-power law, I'm going to be multiplying these exponents. So this will be 3 to the 3x minus 3, using the distributive property, is equal to 2 to the x plus 5. Bases are the same, so we're just going to work in the exponents. 3x minus 3 equals x plus 5. Subtracting 2x and adding 3, or subtracting x and adding 3 will be 2x equals 8, which means x is equal to 4. And just as a quick check of that, let me pull up my calculator. If I substitute x in for 4, this will be 8 to the 3rd at the beginning and 2 to the 9th. And there you see 8 to the 3rd and 2 to the 9th. They're both 512. So x equals 4 checks out. The other way I could check this is if I go to my graph. 8 to the x minus 1 will be one curve, 2 to the x plus 5 is another curve, and when I go to my table, I'm going to scroll through my table until I find the y values are both the same at x equals 4. So just another way for you to check. Last equation to look at. Now here we've got bases of 9 and 27. Now this is a case where I'm going to have to change both bases because I don't know 9 to the something that makes 27. And I don't know, there's no way I can do that in my head. But I do know that 9 is the same thing as 3 squared. So I'm going to substitute that in for the 9. And I also know that 27 is the same thing as 3 cubed. So I'm going to substitute that in for 27. And now we're ready to do our power-to-power law. 3 to the 2x plus 2 will equal 3 to the 3x. Bases are both 3's, so I'm just going to ignore those and work with my equation from the exponents. 2x plus 2 equals 3x. And subtracting 2x to the other side tells me x is equal to 2.